All right, welcome everyone to week 10 for geometry. I have two little activities up on the board for you. Those students who are here in person, we kind of already went over the answers. So if you are watching the recording and you want to try this on your own, go ahead and press pause. But at the top, there is a man hidden in the coffee beans. For those of you at home, did anybody find him? Smiley face, anybody at home find him? One. Okay, so he's actually hiding right here. So he's a bald guy, there's his nose, his eyeballs, so there he's at. And then at the bottom it just says, I dig out tiny caves and store gold and silver in them. I build bridges of silver and make crowns of gold. And everybody hates them. So who is that person? Hopefully this is not you, but it's a dentist. Okay, so happy St. Patrick's Day. Hopefully you had a great week so far. We are going to do the first 5 sections of Unit 3 today. So grab your notes and let's get going. Your Week 10 essential question is coming later in the session, so stay tuned for that. And we are working on dilations today. So I was just sharing with some students who are here that I took my family to Legoland last weekend, and there are a million examples of dilations at Legoland. So what a dilation is, it's an expanding means getting bigger, or contracting means getting smaller, of a shape without distorting the shape. So that means you could have a replica of a ship, maybe in your house, or a model car in your house. Those are called scale models. So at Legoland, they had a scale model of San Francisco, they had a scale model of Las Vegas, they had all kinds of different scale models there, which were super cool. What we're going to focus on today is recognizing what kind of dilation it is, an expansion or a contraction, and also identifying the point of origin. So if you are in your notes right now, can you circle point of origin? And then the third piece to dilations is the scale factor, meaning what kind of dilation is it? Is it times by 2? Is it increasing by 2? Is it shrinking by 1/3? So if it's expanding or contracting, it's going to have a fractional answer. See how here scale factor is giving you a fractional answer? And this is how we're going to be able to find the scale factor today. So put a big star down there by that formula. We're going to be using that. In order to find our scale factor, we're going to take our image divided by our pre-image. It's going to be a fraction. Sometimes it'll turn out to be like 2/1, which is a whole number, which is fine. And sometimes it will turn into a fraction like 1/4. So let's jump in with a Justin Bieber example. Yay, Justin Bieber. I'm just kidding. I'm kind of kidding, but not really. Let me change our polling tools here. I'm going to make them A, B, C, D choices. And I'm going to hide your polling so that only I can see them. Okay, it says which is not an example of a dilation. So I want you to think about it for a minute. One of these 4 is not a dilation. On your paper, if you're in person, circle your answer. And if you're at home, please pick A, B, C, or D. Which one is not a dilation? Meaning, which one is not a distorted version of the original? Okay, everybody at home pick a letter. Even if it's wrong, I'm the only one that can see it. The letters are all at the top of our names in the chat area. Okay, so a proportional sandcastle. That means it's staying in proportion to a real castle. That one's okay. It's just a shrunken version of the original. B says a 20x30 wall poster of Justin Bieber made from a 4x6 photo. That again is just a shrunken version. How can I tell? We're going to come back and answer these in a minute. C says an image of you in a fun house. Have you guys ever been to like a carnival and seen those wavy mirrors? It distorts your image. So this one would be the right answer. That is not a dilation. Dilations do not distort the originals. They just shrink them or expand them. And then a model car would work because it is just a shrunken version. So what we're going to learn today is that, grab my pointer finger here. If something is proportional, that means it's maintaining its integrity, so to speak. It's maintaining its length times width, just in a smaller scale. Look at B real fast. Can you guys actually see what the proportion is? It started off as a 4:6 photo and it went to a 20:30. What did it multiply by to get your big poster? 5 times by 5 times by 5. So that one's also proportional. So the key word here is proportional. Everybody okay with those answers now, if you're home or in person? Has to maintain its integrity, cannot change, cannot distort your figure. So we're going to try one. So find in your notes how I gave this to you already. I highly recommend that you always print the notes, or if you're in person, they provide you the notes, because now you don't have to draw all this. We just get it right on top of it. This one says, dilate the triangle about the origin with a scale factor of 2. There's 2 key parts to this problem. So everybody please underline about the origin. That's huge. So everybody underline about the origin. And then it says my scale factor is 2. Circle the 2. So watch what we're going to do here. Let's all take my A, my point A, and we're going to rewrite it on the side. So if you guys could do this in your blank space or on the lines provided. We are now going to figure out what my A prime is. So what we're going to do is we're going to take my original, and it says my scale factor is 2. That means I'm going to multiply by 2. Can you guys all write that in? We're going to take my original point and we're multiplying by 2. So my A prime is going to be -2, comma, what's 3 times 2? 6. So how did I get that one more time? I took my original point A. A was given to me on my graph, right? It said it's a scale factor of 2. That means I'm multiplying both of those points by 2. -1 times 2, -2. 3 times 2, 6. Questions so far? Everybody okay? Let's try B. B starts off as, if I look over at my graph, 2, 1. Please multiply B by 2. And let's see what my new B prime coordinate is going to be. I'm going to get 4, everybody says? 4, 2. Good job. And my C coordinate starts off as -2, -1. We're also multiplying that by 2. So my C prime is going to become -4, -2. I want you guys to take a minute and graph your new A prime, B prime, C prime. And draw in your triangle. I still can't draw a straight line. I'm trying to connect those points and I'm having a hard time on my tablet here. There we go. Okay, so what we just drew is a dilation with a scale factor of 2. So how did I do that one more time? I took all of my original points, multiplied by 2, got my new points, graphed them all. When am I allowed to use this method? Only when it says about the origin. That's why we underline those key words. Huge. I can only do this method if it says about the origin. Let's try one more time. You might want to make a note of that, maybe on the lines to the right. You can only use this method if it says what? About the origin. That's the only time you can do what we just did. Let's try again. So here's some more dilations. Here it's telling me, here's my pre-image. Pre-image is always what you're starting with. And this is already pre-typed for you on your notes. You're so lucky. I don't like to spend all of our time writing things down. I like to spend it practicing problems with you. So here it's saying my pre-image is this. Don't worry about the bottom one for now. We'll do the bottom one next. Let's worry about the top. So for the top, it says find the image with a dilation factor of 1/2. Let's circle my 1/2. Centered about the origin. Oh, phew, it's still centered about the origin. I can do the same steps I did last time. So let's take my A. My A is 2, 4. This time, what am I multiplying by? What's my scale factor? 1/2. So now please write your A prime coordinate. So take 2 times 1/2 and do 4 times 1/2. So what's half of 2? 1. What's half of 4? 2. Everybody okay? Multiplying by 1/2 is the same as dividing by 2. Let's try my B. B started off as -2, 2. Let's multiply that by 1/2. So your B prime, -2 times 1/2, -1, and 2 times 1/2, 1. Good job. You guys are doing great. I kind of ran out of space for C, so I'm going to put C up here just a little bit. My C is -4, -1. So if I times by 1/2, half of -4 is -2. But what about half of -1? -1/2. Good job. -1/2. I want us to draw A prime, B prime, C prime. Can you draw those 3 points on our graph over here? My A prime, B prime, C prime. So 1, 2, that's my A prime. -1, 1, B prime. And -2, 1/2 is my C prime. This is a really super skinny triangle. I'm going to come back to my pre-image for just a second at the top, and I want to show that to you in blue so that we can talk about what happened. So my original was 2, 4. There's my A. -2, 2. And my C was -4, 1. Oops, no primes, just A, B, C. Whoop. Okay, so look at my blue to my red. What would you say is happening in general? Is it shrinking or expanding from blue to red? What's happening? It's shrinking. So from blue to red, it's shrinking. Maybe that has something to do with the 1/2. 1/2 caused it to shrink. Let's keep that in mind while we try one more. Now I'm going to remove this bottom part, and we're going to be working in green. So this time it still says about the origin. Yay, we're glad it says that. With a scale factor of -2. So this time, what are we going to multiply all 3 points by? -2. But we're always talking about the original points. Does that make sense? Don't go back to your A prime, B prime, C prime. We have to go back to my original. So if my original is 2, 4, I'm going to call this A double prime since this is a new triangle we're making. Can you multiply all of A times -2 and let's see what we get? Thank you, Isaac. I'll go back and fix that in just a second. So A double prime would be -4, -8. For B, if we're multiplying both things by -2, I'm going to get +4, -4. And for C, if I multiply by -2, I'm going to get 8 and -2. Let's watch what happens when I graph these. So -4, -8. Whoa, it's going to be like way down here. -4, -4. That's my B. And C is 8, -2. That's my C. Whoa, sorry. Forgive my wavy line here. So let's talk about what happened. My blue is my original. Again, forgive my wavy line there. It should be a straight line. I just can't draw straight lines to save my life. Let me try and move. There, let me try one more time. From A to C. That's a little better. Not much, a little bit better. So from my original, the blue, to the red, it shrunk. Why did it shrink? We had a scale factor of 1/2. Maybe that means something. Then from my blue to my green, look what happened. It got bigger, but what else do you guys notice about it? Anything else? It got skinnier, yeah. It got like really big, like a lot bigger, skinnier. But check out where your B used to be on top. Where's your B now? On the bottom. Look at my scale factor. It was a -2. What do you think caused that one to flip upside down? The negative. Good job. So what I wanted you guys to see on this example is when we have fractions, what's going to happen to my new image? It's going to shrink. If I have negatives, what's going to happen to my new image? They're going to flip. So kind of interesting. And what Isaac pointed out is I graphed C incorrectly on my red one. Thank you for catching that. It was supposed to be -2, -1/2. So that one actually would have been down there. A little bit better of a triangle there. So thank you. I make mistakes too. It's Friday. Oh, the last thing. The most important part was centered about the origin. Centered about the origin. Anytime it's centered about the origin, we're allowed to just multiply my coordinates by the scale factor. So what if it doesn't say that? What if it says this? This says pre-image triangle PQR. This is a homework question, by the way. Hint, hint. I'm doing your hardest homework problem with you right now. Under a dilation with a scale factor of 3, let's circle that 3. We know that 3 is important, right? Anytime it says scale factor, that's important. And a center of dilation of -5, 2. That's weird. It doesn't say centered about the origin anymore. This time it's saying that my center is C. So on your graph that I already gave you, you guys see how they plotted a C? C is your center of origin. So watch how I have to do this one. This is weird. Kind of strange, kind of weird. This time, since this is my center, I still know it's going to be a scale factor of 3, which means all of my sides are going to be 3 times longer than what they were originally. I do know that. So I know that this, even though it's 2 right now, what's it going to end up being? 2 times 3, it's going to end up being 6. If QR is 1, what's QR going to end up being? 3, right? 1 times 3. So we know that these sides are going to end up being 3 times longer, but I don't know where to draw my triangle because it's not at the origin. It's at this weird point. So these are the steps you have to take. We have to draw lines from the center of origin, from the center of dilation, through each of the vertices. So I'm going to draw a line from C through P. Then I'm going to draw a line from C through Q. So let's do that together. So C to P, we're going back to algebra for a minute. Let's look at that slope. It goes up 1 over 1. I have to continue that same line. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So go ahead and draw that line. These are going to be the steps you always have to follow if your center of dilation is a different coordinate than the origin. Let's do that one more time. Now I have to go from C through Q, and that one goes down 1 over 1, down 1 over 1, and we're going to just draw that line all the way down. Everybody okay? I have one more line to draw. My last line has to go through my last coordinate. So this one's going to go between C and R. So to get from C to R, I'm going to go down 1 over 2. Everybody still with me? Down 1 over 2, down 1 over 2. So I have my 3 crazy lines. They always go from your center of dilation through each of the vertices. So this one was drawn through P, this one's drawn through Q, this one's drawn through R. From here, here's where it gets tricky. My new triangle is going to fit somewhere in between these lines. That's why we had to draw them. My new, bigger triangle. We know it's going to have a scale factor of 3. So my QR, we said, is 1 right now. I know it has to be 3 spaces long. Your vertices of your new triangle have to lie on these new lines. Meaning, if one dot is going to go here, your next dot would have to be here. Your dots always have to lie right on the coordinates. So watch how I can find this one. I know that the bottom of my triangle is going to have to go through both of these 2 lines. So that means there's only 2 spots where it's going to cross. And these are weird. I know, they're super weird, super strange. So if I'm looking at this line right here, going straight across, I know it's going to have to hit this line and this line. So I'm going to put 2 dots right there. Since this is still a triangle and it's a dilation, that means it's the same shape as my original. So it's also going to have a length that goes straight up. So I'm going to go from my first dot and draw a line that goes straight up to right here. So look how I found those coordinates one more time. I knew that here's my old shape. I know my new shape is going to be the same shape, just bigger. Your new coordinates have to lie on these red lines that we drew. They have to. So going straight across, it has to be on both of those lines, and then we know that this part of my triangle is going to go straight up. So if I draw my triangle in here now, let's see if I did a good job. So across the bottom used to be 1. Across the bottom is now 3. That's what it's supposed to be, scale factor of 3. Straight down the side used to be 2 spaces. Now it should be 6. 1, 2, 3, 4, 5, 6. So there's your new triangle. So it's not as easy if they don't say center of origin. Then you have to use these wacky, funky steps. So I gave you this extra slide in your notes that has all of this at the bottom for you guys to read through later about why we go from this one to this one. But again, this is what I just drew with you. It just has all of these coordinates matching on your intercept line. So at least you have an example. There's not very many of these. I think there's 1 or 2 on the homework, and this is as hard as it gets, so I did it with you. So let's go over some facts about dilation. Scale factor. If your number is between -1 and 1, I'm talking fractions here. Can you circle that word fractions? You're going to shrink your original object. So what kind of numbers are we talking about? 1/2, 1/3, 1/8. Anytime you get a fraction, that's shrinking. Then in red it says if you have a number less than -1 or greater than 1, it's going to expand the object. Remember that one time when I had that -2 and it was bigger? And we're like, why is a -2 bigger? Because anytime you have those whole numbers, it's getting bigger. What does the negative do to it? That's our next little point right here. Negatives change the orientation, meaning they flip the object around. So if your scale factor is a 4, if your scale factor is a 6, if your scale factor is a -9, all of those are actually enlarging your object. All of them. If it's a negative, it's flipping it upside down. Do you see the difference? So the only time it's going to shrink is when you have what kind of a number? A fraction. When is it going to get bigger? Every other time. And then this last one is what we just talked about. The point of dilation will affect the location. That's very true. So let's write this in our notes. On your line section of your notes, write this down. If it says origin, then you can just multiply by the scale factor. That was the easy one. Right? If it says dilate around the origin, you could just multiply by the scale factor and plot your point. We like those. Those were super fun. But if it's centered around another point, so let's write that. If it's centered around another point, Then we have to do what we did on the last problem. Remember how we had to draw those extra lines through the vertices? We can write that in. So we have to draw lines through vertices. We know vertices is just a plural word for a vertex, right? The very corners of your shape. And in parentheses, you could always say, see last example, or draw an arrow pointing at your last example to help remind yourself. Oh, it's on the other page? Bummer. Just put see last example or something like that. Okay, so that last problem is as hard as the homework gets for the first section, which is why I did it with you. Now we're going to get into finding the scale factor, meaning before I was telling you, hey, this has a scale factor of 1/2, draw it. This time I'm going to show you the two drawings and I'm going to ask you what the scale factor is. So we're either going to have to find that whole number, that negative number, that fraction. So here's your first shape. The pre-image is FGDE. I'm going to highlight that in blue, bluish green. FGDE. That one is your pre-image. And the dilation image is the F prime, G prime, D prime, E prime. So that's the image. The image is this one. It's important to know which one's the pre-image and which one's the image because it starts as the pre-image and it becomes the image. So think about what's happening. It starts as the green one and it turns into the yellow one. So before I even find the specific number, is it shrinking or is it getting bigger? From the green to the yellow. Shrinking. What kind of number do we know that shrinking is going to mean? A fraction. See how we know a lot before we're starting. So how do we find this number exactly? There's a little formula for it. And it is the image divided by the pre-image. Can you add this to your paper? Image divided by pre-image. Hint, hint, this might just have to do with your essential question at the end of the day today. Okay, so the image is the yellow one. What does it mean by image? What does that mean? What do I need to put in there? The length of any side. So let's pick a side. Let's all pick DE. So DE has a length of what? 1. So my image has a length of 1. Now look at your pre-image for the same side, the coordinating matching side, D to E. How long is your pre-image? 4. What's your scale factor? 1/4. That was not hard. It's not hard. Okay, so scale factor. Let's write that in. 1/4. There's no catch. I love that question. There's no catch. So how are you going to find scale factors? Image divided by pre-image. Now if you're saying Mrs. G, but what if I don't pick the same side as you? You're going to get the same answer. So let's try. If I pick EF, 1 divided by 1, 2, 3, 4, 5. Okay, so I lied. So that side is the one. Oh, here's why. It's not a 1. Why can I not pick EF? Anybody see it? Yes, it's not exactly on a coordinate. See how it's over just a little bit? Since I don't know exactly how far that one's over, I can't use that one when I'm finding my scale factor. I'm glad I picked that one to try. Could I pick DG? Sure, because those go through perfect coordinates. So that one's 1/1, 2, 3, 4. So that's 1/4. Your scale factor will be the same no matter which side you choose, okay? I promise. I promise. So sometimes there's just points we can't choose because we can't see exactly what spot that's at. That was a good one to pick. I'm glad I picked that side. So before we go any further, stop, right? We're going to do a little ratio proportion practice because in order to use these techniques we just did, your shapes have to be proportional to each other. Meaning your original and your new one have to be the same shape and have to maintain its integrity. They can't be distorted. So anybody remember what to do when I have two fractions with equal signs in between them? One thing I could do is cross multiply. So let's try that on the top. So if I do 3 times 10, does that equal 6 times 5? Yes. You just check to make sure they're proportional. There's another way that I can check that things are proportional. Let's try the other method with this second example on the bottom. What else can I do to check that they are proportional to each other? Anybody know? Close. So the first one was multiply, cross multiply. The second one, I circled the 8 over 10. What can I do to the 8 over 10? I can reduce it. Yeah, I can reduce. So 8 over 10 is the same as, if I divide by 2, 4 over 5. Oh, they're the same. So I have two ways for checking if proportions are the same. I can cross multiply or I can reduce. Everybody okay with those two ideas? And you're thinking, why do I need this? I'm going to show you in a second on a picture. Because if I show you two shapes and I say, are these dilations of each other? You're only going to know if they're dilations of each other if their proportions work. If their proportions work, then you can say, yes, they are dilations of each other. Okay, I threw in this little slide on some algebra review for you on some of your properties. We're not going to take time to do them. We actually did the first one together today, which is when you cross multiply. But I'll leave those here for you. So there's more than one way to check that you have a proportion. Do you guys remember when we learned triangles and we learned about congruence properties like side, 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 angle, side, angle, side, angle? We did all those a long time ago. Those were congruence properties. Congruence means all the angles were the same, all the sides were the same. This unit, we're dealing with this new word, similarity. Can you draw this symbol on your paper? It's like a wavy line. A single wavy line means similar to. So a single wavy line, make sure that's in your notes, means similar to. So how are you going to be able to tell me that shape number 1 is similar to shape number 2? Let me show you how. You're going to set up a proportion, and we're going to make sure that they work. Watch how easy it is. I can say, is 2 divided by 4? See how I picked the same side on each shape? I picked the left-hand side, their corresponding side. Is 2 over 4 equal to, I can pick any two other sides I want, 2.4 over 4.8. 0.4 over 4.8. There's two ways I can check. Right now I'm going to put a little question mark above my equal sign because I don't know if they're equal yet. I have to check. What are the two ways you can check? You can cross multiply or you can reduce both sides. See how you have two choices. Whatever way works for you works for me. So I'm going to reduce. 2 over 4 is the same as 1/2. And 2.4 over 4.8 is the same as 1/2. My proportions were the same. So guess what I can say about these two shapes? They are similar. So we're getting away from congruent now. We're talking similar. So let's write it like this. We're going to say EFGH is similar to, so I'm using my new symbol here. Make sure this is in your notes. Similar to, is order of my letters important? Very, very important. Whatever order I do on my first shape, I have to do the same order on my second shape. JKLM. There we go. Does it matter which way you write the squiggly line? The answer is actually yes. So it starts at the top, goes down, and then it comes back up. Then it's not the similar to symbol. It's just a squiggly line if you do it the other way. So what we're going to do for the rest of the day and the rest of this week, beginning of next week, is you're going to be proving to me that two things are similar. How do you prove that these are dilations of each other? You set up two proportions, and they have to equal each other. If they're equal to each other, yes, they're similar. What if these two did not equal each other? Then what would I say? They're not similar. There you go. You hit the nail on the head. So I have one more example for you. Let me have you practice this one. It says, is triangle DEF similar to triangle NOM?
I didn't know math had grammar.
Totally.
Nom.
Nom. Okay. So on your paper, please set up two proportions, and I want you to check. Are they similar to each other? Are they proportional to each other? I know. One of them is flipped. I did that on purpose. So the question becomes, even though one's flipped, yes, you have to sort of twist it in your head so that they are facing the same way before you set up your proportion. So like, for instance, if I pick 10 on my first triangle, I have to make sure that I match that up with the right same side on my other triangle. 10 is my hypotenuse. So what side does 10 match up with on my other triangle? 15. Yep, MN. So does 10 over 15 equal, and I can pick any other one I want. So I will say 6. So 6 would match up with the 9. If you have any questions, what you can do is on your notes, take your paper, put your finger like right here on this dot, and just twist your paper around. Then they're in the same orientation. Does that make sense? Then you can sort of match up. This side goes with this side. So two ways to do it. I can cross multiply if I want. I get 90 equals 90. Or I can reduce. 10 over 15 is 2/3. 6 over 9 is 2/3. So I am allowed to say that they are similar to each other. We cannot say congruent. Think about why. One side's 10, one side's 15. Congruent means exactly the same. They're not. They're different numbers. Similar means they're in proportion to each other. Do you guys see the difference? So congruent means exactly the same. Proportional means that they are similar to each other, meaning if we take their proportions and we reduce them, they are the same. So this kind of goes through how you could set up any two of the three sides, and by the time you reduce them all, they are all the same. So that's how you prove something is similar. Your Week 10 essential question today is to describe how to determine what the scale factor is when given a pre-image and an image. So I'll give you a minute to copy that down. We did an exact example of this in your problem set today. I had you put a star by it. The problem said, what is the scale factor? And then I gave you a picture of the pre-image and the image. So make sure you get that answer into the Dropbox. And I hope you guys all have a fabulous Friday. I'll stick around if you have any questions.